Hi guys, welcome to NEET World Institute and NEET World YouTube channel. Yes, so in today's class we are going to concentrate on class 11th IPE. So especially for both Telangana and Andhra. Okay, and the thing is, in today's class we are going to do the short answer questions, that is SAQs. Okay, so in last class we have completed the motion in a straight line, right? So in today's class we will see laws of motion. Okay, so yes, this is the first question. Okay, so we need to explain the advantages and disadvantages of friction, right? So first thing, try to understand what is the meaning of friction. Okay, so the meaning of friction is it's opposing force, right? No, so in this question they have asked two things, one is advantage and one is disadvantage, right? So what is the thing they are asking for advantage and disadvantage? Asking for friction. So friction is the opposing force, right? No, it's opposing force, right? So I need to write advantage for opposing force and disadvantage for opposing force. When you are feeling this opposing force, when you are feeling the like friction, when we are walking on a road, when we are walking on the surface, a rough surface, right? No, so for the smooth surface, like the friction is negligible, we can say, right? No, okay. So here advantage of the friction, first thing, okay, the first point, it helps us to walk on the floors, right? So next is motion of vehicles are possible due to friction. This is the first point. Okay, next point is nails, screws, etc. are driven into walls. So wooden surface, etc. due to friction. Okay, next point, what we can say, like the thing what we are writing here advantages, no, like in day to day life whatever we are using, like whatever we are doing, everything we can write it. And what is the disadvantage also we can write. Okay, so writing with a pen, like if some rough surface is there only we can write that, right? No, pencil or holding an object with hand, like if you see your hand, no, like it is a rough surface, right? No, so with hand, etc. is possible due to only friction, right? So a matchstick is lightened due to friction. Obviously when you are talking about the olden ages, no, like they used to rub the stone, so because of the stone is rubbed, no, like the friction has been taken place. Like when you talk about stones, it's a hard surface, it's a rough surface, we will say. When we are rubbing the both hard surface or rough surface, no, the friction taken place, right? No, both are opposing to each other, so obviously the heat will be produced. Okay, the heat will be produced. So first point, walking on the floor, a motion of the vehicle, we can say. Next is nails, screws are driven into the walls. Okay, and third one is writing with pen, pencil in the books, okay, and holding the books also. And the fourth point, matchsticks is lightened due to friction, and you can add some more examples also. Okay, so we should mention what it is particularly, like the thing is, no need to write the exact points, we can write our own points also, but it should be valid. Okay, next, disadvantage of friction. So wear and tear of machine parts are due to friction. Okay, energy is wasted. What energy is wasted? Heat energy, right? No, energy is wasted as a heat due to friction, which decreases efficiency of engine, obviously, and friction results in larger amount of power loss in engines, right? So these are the advantage and disadvantage of the frictions. Okay, you can take a note of this and we'll go for the second question. Okay, and before that, one more point we can include, like how we can reduce that friction also. Okay, so you can take this point and we'll go for the next point. Okay, Ravi, sports lover, hi, hello, good afternoon. Done? Okay. So the next is we'll see how to reduce this friction. Okay. So reducing the friction is the next question. So mention the method used to decrease the friction. So first part of the question, like first question what they have asked, what is the advantage and disadvantage, right? No. So when we are talking about disadvantage, right, like there should be some method to overcome the disadvantage. That is the second question here. Okay. Mention the method used to decrease the friction. So method to reduce the friction, first one is polishing, second one is ball bearing, third one is lubricant, and fourth one is streamlining. Okay, streamlining. So first one, polishing. So what is the meaning of polishing? Like polishing the surface in contact decreases the interlocking and thereby friction can be reduced, right? So when you talk about the marbles, no, like the marbles on the floor, it's are polished, right? No, from where we are getting the marbles? From the rocks only. So obviously when we are talking about rocks, it's a hard surface. When we are polishing that surface, it will become like a marble, right? So marble are polished to become smooth. So second point, ball bearing, where we can get the term, like we are using the term ball bearing like in the vehicles, right? No. So ball bearing can reduce the rolling friction. Yes, the vehicles. When we are talking about vehicles, no, like in the tires, like the due to like rolling friction, we are using the ball bearing. Okay, reducing rolling friction, since rolling friction is less than the sliding friction. So example, ball bearing are used in automobiles and machines. Okay, and the third one is lubricant. So lubricants like a grease from a thin layer between the surface in contact, it reduces the friction, right? So lubricant are used in machines. And streamlining, so automobile and aeroplanes are streamlined to reduce the air friction. Okay, so these are the 4 points we can use as a method to reduce the friction. One is polishing, second one is a ball bearing, third one is a lubricant, and fourth one is a streamlining. Okay, you can take a note of this. Done. Can we go for the next one? Okay, so the next question is, state the law of rolling friction. Okay, we are coming one by one. Okay, so the third question is rolling friction. So we have seen some rolling friction in the previous case. So where we have seen in the ball bearing, that is vehicles, automobiles we have seen, right? So law of rolling friction, first thing. So the smaller than the area of contact and lesser will be the rolling friction. What they are saying is, when area of contact is smaller, no, the rolling friction will be less. Okay, when the area of contact is larger, okay, so area smaller the area of contact, lesser will be the rolling friction. Suppose like when I talk about area of contact is high, then rolling friction also will be high. Rolling friction also will be high, right? So larger the radius of rolling body, the lesser the rolling friction. Next point what they are saying, larger the radius, if smaller radius is there, rolling friction will be somewhat, I will take 5, okay, for example, or let me take this as r1. And when I talk about radius bigger, no, so rolling friction will be less. Okay, for this rolling friction will be I, for this the rolling friction will be less, because the larger the radius rolling body, the lesser the rolling friction. First point, lesser the area, lesser the rolling friction. Larger the radius of the rolling body, lesser the rolling friction. Okay, the rolling friction is directly proportional to the normal of the surface, like normal reaction, right? So friction is directly proportional, no, friction is directly proportional to n, so F will be equals to mu n. Similarly, rolling friction, Fr is directly proportional to n, so Fr will be equals to mu r into n. So what is mu r? It is coefficient of rolling friction, okay. You can take a note of this. Done? Completed? Okay. So this is the law of rolling frictions. And when we are going for the next one, so where mu r is the coefficient of rolling friction, okay. So this is about the rolling friction, okay, no. So this is for the third question. Next we will see the fourth question. So what is fourth question? States Newton's second law, okay. So Newton gave us three laws, like first law, second law and third law, right. So second law, what is the second law? Like when we are talking about second law, like something we will remember, like force equals to mass into acceleration, okay, fine. But before that, one more point is there, how we got that force equals to mass into acceleration, okay, that one we will see here. So hence derive the equation of F is equals to ma, okay. So that's the thing. So Newton's second law states that the rate of change of momentum of a body, is directly proportional to the external force. So what is the meaning of this rate of change of the momentum? Momentum is P, like rate of change, no. So dP by dt directly proportional to F, right. So acting on a body and it is in direction of the force. Acting on a body, like what force is this? External force, okay, this external force, okay. Yes, you can take a note of this. Okay, done. Okay, so now we have got the equation. Now what we know is momentum is nothing but mass into velocity, Let me write that mass into velocity divided by time is equals to force, okay, is equals to force. When we see this velocity by time, what is velocity by time? Acceleration is equals to velocity by time, no, right? So can I write now like this, mass into, okay, mass will be constant, so dv by dt will be equals to f. What is dv by dt now? Like it is acceleration, so m into a will be equals to f. So force will be equals to mass into acceleration, okay. Okay. So what will be F? F is nothing but external force, and A is nothing but acceleration, and yeah, let me write here, this is acceleration, and mass is, so M is nothing but mass. Okay. So in this, what is the terms that we are using? Mass, velocity, velocity, time, this is acceleration. So hope you understood this concept, right? And we have derived the equation also. Okay. That's the fourth question. We have stated what is Newton's second law, which is nothing but rate of change of momentum is directly proportional to the external force acting on a body and in the direction of the force. Okay. So next one, next question. Yes, if you see here, F is equals to ma. Okay. So we have derived the equation. So F is equals to k into dp by dt. What is, yes, what is p? It is mass into velocity. So k into m into dv by dt. So where if we take k as 1, we will get F is equals to mass into acceleration. So next is fifth question. So what is pulling the lawn roller preferred to pushing it? I like why it is pulling a lawn roller preferred to pushing it? Like pulling preferred to pushing. I need to explain why it is. So when we talk about pulling the lawn roller, so let the pulling the lawn roller with the force F is applied on the roller. Okay. So the vertical component of the applied force is F sin theta. So what is the vertical component they are saying? Vertical component means what? Like it is in the y axis, we'll say, right? No. So when we are pulling the lawn roller, okay, so it will be F cos theta, and upside it is F sin theta. Okay, acting upward direction and reduces the normal reaction. So the normal reaction becomes, how it becomes? So normal reaction will be, this is n, and downward it will be mg, no. So n plus, let me write the equation, n plus F sin theta will be equals to mg. This is one thing. What is normal force now? It is mg minus F sin theta. Is it reducing? No, because the minus term is acting over there. Okay. So when you see this equation, n plus F sin theta will be equals to mg, where n is equals to mg minus F sin theta, right? So look at the diagram here. So when we are pulling, no, like the angle will be formed here. So it is sin theta, and this is my cos theta. This is my mg, and the friction will be in opposite direction. So F cos theta will be equals to friction, and when we are pushing it, okay, pushing in the sense, like a normal reaction will be equals to mg plus F sin theta, like it is more, like normal reaction is more, right? So if you see here, when roller is pushed with the same force with the same angle, then the vertical component of applied force F sin theta will act downwards. It is downwards. Okay. Here when we are pulling it is upward, when we are pushing it is downward, and cos theta will be in the same direction, no change in the cos theta, only the sin theta value will change when we are pulling or when we are pushing it. Okay. So here normal reaction will be mg plus f sin theta. So if you see here, normal reaction is more here, in normal reaction is less here. So where it is less, it is pulling in less, when pushing is more. So why is pulling the lawn roller preferred to pushing it? Okay, now you understood. So normal reaction will be less there, so I can pull. Here normal reaction is more, so I can't push it. Okay. So this is the fifth equation. You can take a note of this fifth equation. This diagram is the important thing. When we are explaining with the diagram, it will be more helpful for the examiner how we have written the equation, I mean answers. Okay. Done. Can we go for the next one? Okay. So the next question is, define the term momentum and impulse. Okay. So state and explain how the law of conservation of momentum. We need to explain what is the law of conservation of momentum, and I need to give some example for that. So first thing, momentum is nothing but, we know the formula, it is mass into velocity. When change in momentum, if we talk, it is impulse. Okay. Yes. And other formula for impulse is force into velocity also we can say, I mean force into time we can say, not velocity, force into time. And if you see here, the product of mass and velocity of a body is called the momentum of a body. So when we talk about impulse, no, like impulse we can say it's a change in momentum, or else it's a force into time. How we are saying force into time? So force is nothing but mass into acceleration and time we have taken. So time, acceleration is velocity by time, time will get cancelled and it is velocity, right? No. So momentum is nothing but the product of mass and velocity of a body is called as momentum of a body, right? So P is equals to mv, P is equals to m into v, where m is mass and v is velocity. Okay. Now impulse, the product of, here product of mass and velocity, here product of force and time, okay, produces a finite change in momentum, finite change in momentum. I can say it is delta p also. Delta p is nothing but m into v final minus v initial. This is the formula. Okay. So either we can write force into time or else mass into change in velocity. Okay. Like why we are not talking about this mass has not changed? Mass will be always constant, it doesn't change. So mass always constant. Okay. So this is denoted by the symbol I and this is denoted by the symbol P. Okay. This is about momentum and impulse. So when we are talking about law of conservation of linear momentum, so in absence of external force, like when there is no external force, no, when there is no external force, yes, when there is no external force, the momentum before collision and the momentum after collision, momentum before and after collision are same for an isolated system. Isolated means like it's a closed system, we will say. Okay. So this is law of conservation of momentum. When we are saying law of conservation of momentum, when there is no external force, okay, when there is no external force, then we can say like we can say the law of conservation of momentum has taken place, right. So here we will give explanation how we are explaining that. Okay. So consider two particles of mass m1 and m2. Okay. So moving with velocity, let me give a diagram over here for this case, so it will be easy to understand. So when I am talking about mass m1 and mass m2, it's moving with velocity u1 and this is u2. This is when means before collision, and after, like during collision, no, this is m1 and this is m2. This is during collision, and after collision what happens is mass 1 will go with velocity v1, mass 2 will go with velocity v2. This is after collision, right. So this is about the diagrammatic points. Okay. So before collision, no, the momentum will be m1 u1 plus m2 u2. After collision, no, it is m1 v1 plus m2 v2. We know that according to the law p1 is equals to p2, right. So m1 u1 plus m2 u2 will be equals to m1 v1 plus m2 v2, right. So this is the explanation for the law of conservation of momentum. So next one, example, when a rocket is fired, the fuel burn and releases exhaust gas downward. So rocket will go upward, the fuel gas will exhaust downward. As a result, the rocket move up with the equal and opposite momentum, right. So after explosion of a bomb, two pieces move with equal and opposite momentum. These are the two examples, right. You can take a note of this. Done? Okay. The next question is, yeah, this is the last question of the class. Okay. A batsman hit back a ball straight in the direction of the bowler. Okay. So straight in the direction of the bowler means like there will be a 22 yards. Okay. There will be a 22 yards cricket. Yes, no, cricket pitch. So batsman will be here holding the bat. Okay. And bowler will be here. Now what it is doing is, a batsman hit back a ball straight in the direction of the bowler without changing its initial speed. So initially bowler releases the ball with a speed 12 meter per second, they are saying. If the mass of the ball is 0.15 kg, okay, he is taking the ball and the mass of the ball is 0.15 kg, right, which is nothing but I can say it is 0.15, no, so we can say 15, like it's in gram also, like in gram also we can mention, but in gram it is too less. Okay. So determine the impulse imparted on the ball. So impulse imparted on the ball, impulse in the sense it is force into time, one thing, impulse is equals to force into time, or else I can say mass into change in velocity, final velocity minus initial velocity, right. So here it is, why, like change in velocity is there, and one more thing we need to assume that direction of the velocity also. When I talk about this velocity, it is positive direction and this is negative direction. Which is negative direction? Yes. So initial will be coming from say going in positive and this is negative. Okay. So either you can assume either in the opposite direction also, it is negative or it is positive. Any one you should assume. Okay. When we are doing that, like velocities will added up, right. So mass is how much? It is 0.15 and velocity will be how much? 12 plus 12, 12 plus 12, 24 will come, right. So it is 0.15 into how much? It is 24. So I can say it is 15 into 24 divided by 110. So 2 zeros. Okay. So 240 plus 120. So 360 will come. No, 360 divided by 100. 10 and 10. It is 3.6. 3.6. Either I can say it is a Newton second. Okay, Newton second also I can say. Right, no? Mass is nothing but like mass and velocity they are given, or else kg meter per second, kg meter per second, right. Either I can say Newton second or kg meter per second, this is the thing. So change in momentum will be 0.15 into 12 minus of minus 0.15 into 12, that is the thing we have done here. Okay. So in the direction from the batsman bowler, like it is imparted is 3.6 Newton second or kg meter per second. Okay. Yeah. So up to this is laws of motion short answer questions. Okay. So we will continue with the next part of the lesson in the upcoming session. Okay. So thank you guys. We'll meet in the next class. Bye bye.